In this video, I'm going to be explaining the solution for number 7 from the chapter 4 purple paper. The question for number 7 is, what is the concentration in molarity of sodium ions, so just that sodium ions, in 3 liters, in this 3-liter solution containing 10 grams of sodium chloride and 7.5 grams of sodium oxide. So the first step, whenever you see a problem, is you need to underline or highlight the important information. So what we are looking for is the concentration, and we are given 3 liters and 10 grams of sodium chloride and 7.5 grams of sodium oxide. So now we need to be thinking about what steps we need to take in order to get the solution. So the goal of this is to figure out the concentration in moles per liter. Okay, so concentration, molarity, we want to figure out the molarity. Molarity is moles per liter. Okay, so looking at this problem, I have liters already, but I don't have moles. But I really want to find molarity, so I know that I'm going to need to find moles before finding molarity. I am given grams, so the next idea I had is to convert from grams to moles, because this would allow us to figure out what the moles were, and then we could figure out the molarity. The last thing to note is we are just looking for the molarity of sodium ions. So we're not looking for the molarity of the entire solutions. We are just looking for the molarity of sodium ions, which means that my moles, this should just be sodium ions. When I convert to moles, I'm going to have to convert to sodium ions. So I take my first solution, my first compound, my sodium chloride, and I have 10 grams of sodium chloride, and I convert from grams of sodium chloride into moles of sodium chloride by using molar mass. Then I convert from moles of sodium chloride into moles of sodium ion. So notice, for every 1 sodium ion, we have 1 mole. For every 1 mole of sodium ion, we have 1 mole of sodium chloride. If we had 2 moles of sodium ions, then we would have 2 moles of sodium chloride. And after doing all that math, I end up with 0.171 moles of sodium ions. I want you to pause the video and try and figure out how many moles of sodium ions we have in 7.5 grams of sodium oxide before moving forward. So, just like we did with the sodium chloride, I take my initial grams of sodium oxide. I convert from grams of sodium oxide into moles of sodium oxide using molar mass. Then I convert from moles of sodium oxide into moles of sodium ions. I see that there are 2 sodium ions for every 1 of those compounds. So there are 2 moles of sodium ions for every 1 mole of sodium oxide. After doing the math, I get 0.24 moles of sodium ions. So we have 0.171 moles of sodium ions from this solution, and we have 0.24 moles of sodium ions from this solution. We want to know the concentration of all of the sodium ions, so we add them together, and we get 0.41 moles of sodium ions total. I want you to remember, when we add with our significant figures, we take the least precise digit. So notice that the hundredths place is less precise than the thousandths place, so we're going to round our number to the hundredths place. Okay, our next step is to take our moles of sodium ions and our liters of solution and determine the concentration. So pause the video and see if you can determine the concentration. So molarity is moles per liter, so all I do is plug in my moles of sodium ions, divide by my liters of solution, and I get my answer of 0.14 molarity. So that's moles per liter. That's all.